In this video, we'll talk about how to write a linear equation from a graph. There are two key pieces of information we need to write the equation of a linear function. One is the slope, and the other is the y-intercept, or we can use any point if we use point-slope form. So I'm going to start by finding my slope. Remember that slope is equal to the change in y divided by the change in x. So in order to find my slope, I'm going to look at 2 points on the graph. I can use any two I want. And I'm going to see what's the change in y. How much am I going up or down in between those points? And what's the change in x? How much am I going left or right? So I'm going to use the points 0, 5, and 3, 3 on my graph. And I'll notice that in between those points, I'm moving down 2 in my y values. And I'm moving over 1, 2, 3 in my x values. So that means that my slope in this case would be -2/3, because -2 was my change in y and 3 was my change in x. Now at this point I can write an equation in point-slope form if I want, which is up on the right here. So remember, it's y minus y1 equals m times x minus x1, where m is our slope and x1 and y1 are coordinates of a point on the line. So I'm going to set up my equation. M is my slope, which I just found to be -2/3. I'm going to subtract from y the y coordinate of a point on the graph. You can use any point you want, but I'm going to use 6, 1. The y coordinate of that point is 1. So in my equation, I'm going to subtract 1 from y. And the x coordinate of that point is 6. So in my equation, I'm going to subtract 6 from x. And now I have an equation for that graph written in point-slope form. If I wanted to write it in slope-intercept form, I would need to identify the y-intercept. Well, the y-intercept is where the graph crosses the vertical y-axis, which is this line here. So if I look along that vertical y-axis, that yellow line, and see where does my graph intersect it, I'll see that that happens at this point, 0, 5. Remember too that the y-intercept is always the y value when x is 0. So here when x is 0, the y value is 5. So that means that my y-intercept is 5. Now I can write an equation in slope-intercept form, which is y equals mx plus b. M is my slope, which I found above to be -2/3. And b is my y-intercept, which is 5. So either of these are correct equations to describe the function that we see in the graph there. But what if I have a graph where I can't see my y-intercept? So the process is going to start the same. I'm going to find my slope, which is my change in y over change in x. Again, you can use any 2 points you want. So in between these points, I'm going up 1, 2, 3, 4. And I'm going over 1, 2. So my slope would be 4 over 2, which is just equal to 2. So again, at this point, I can write an equation in point-slope form by using any of these points. For example, this bottom point has coordinates -8, 9. So I could write my equation as y minus 9 equals my slope 2 times x. And if we think of this as minus a -8, we can write that more simply as x plus a +8. So that's one way to write the equation without solving for the y-intercept. If you did want to solve for the y-intercept, we will write our y equals mx plus b equation, and we found our slope m to be 2, so I'm going to plug in 2. And now I can plug in the x and y coordinates of any point on my graph in order to solve for b. So I'll stick with that same point, -8, 9, and I'm going to put -8 in as my x value. And I'm going to put 9 in as my y value. Now I have an equation that I can solve for b, my y-intercept. So 2 times -8 is -16. I will add 16 to both sides of the equation, and I'll get that my y-intercept is 25. So then I can go ahead and write an equation in slope-intercept form. Y equals my slope 2 times x plus my y-intercept, which is 25. So either of these are correct equations for the graph shown.